Alright, so we are done with the understanding of different firewall design aspects. Now let's move on to the packet filter firewall, known as access control list. Now, one of the first firewall which was made available in networking was packet filter firewall, and it was implemented on router. Keep in mind that the first firewall product which was introduced in the industry was by Checkpoint in 1994. So the patent for the stateful packet inspection till date lies with Checkpoint. We're talking about 1990 when we introduced a firewall concept on a router. Now this is interesting because a router was never supposed to be a security device. It was a internet networking device meant for providing fastest forwarding. You see, all networking devices, whether it's router, switch, you focus on fastest forwarding. We measure their efficiency by how many packet per second or kilobits per second, million bits per second, etc. What's the throughput? These are the things which are important. Also, we dig deeper the internet operating system of a router or a switch, the hardware, different kind of packet switching technology, fast switching, you have multi-layer switching, Ceph being a recent one. We are using dedicated ASIC for forwarding. So the entire effort for an internet networking device is to ensure that they are capable of forwarding at the fastest rate. Now, what exactly is a router switch forward? So they forward a packet. Okay. Now I need to get one thing clear. Packet. So what exactly are we talking about? Okay. So let's get a bit of an OSI sorted out here. Let me open a notepad. Okay. Now, when you talk about a packet, so this word comes at three layers. It comes at OSI transport layer, it comes at network layer, and it comes at data link layer, also known as link layer. Okay. Above transport and below data link layer, we do not have a definition of packet. Now, above transport layer, the three layers which we have, application, presentation, session, they are user, and these layers are dealing with the data. So when you talk about session, or above it we have a presentation. Oops. And the topmost in the stack is of course application layer, right? So the top three layers are basically dealing with data, and data is what end user requires. However, transmission devices have a different requirement altogether. Transmission devices like courier boy, delivery boy, they are not going to get the package. They're just supposed to courier it from one destination to another destination. Now for forwarding, I don't require what are the contents. I really don't need to know. It's not meant for me, so why should I? Makes sense. So as far as the courier boy is concerned, well, you are concerned about what is the destination and how to get the destination in the fastest possible manner. So we have a generation of packet. Basically, you are converting data, breaking data into multiple packets. Loosely, the term packet is used to transport, network, and data link layer. If you want to be specific, you can say, well, transport layer we use segment. We have TCP, UDP coming over here, and then all kind of port numbers comes into picture. What is a port number? Well, port number is an address of an application. You reach the server using an IP address or a MAC address, right? But how do you address the application or a service? So the port address defines the logical address of that application, that service. Okay, I'm sure you're aware that the port numbers from 1 to 1023 are well-known port numbers, like port number 80 reserved for HTTP, 23 reserved for telnet, so on and so forth. And 1024 to 65,535, that is a range available for private ports. Okay, I'm going to come to this port part, how the client-server communication works in a moment. But just a very brief look at this. So TCP, UDP are the two protocol at transport layer, connection-oriented, connectionless. If you are getting into firewall, well, you got to know this part very well. Okay, so yeah, we will be taking a little bit deeper look into these things. What are the TCP handshakes? How the communication happens in a connection-oriented manner. Now network layer, we have protocols like IP, you can have ICMP, you can have GRE, you can have OSPF stuff. Okay, the addresses which we are getting is IPv4 and v6. This is what we get at transport network layer. Now, mostly our firewalls are coming in network layer. Okay, they are capable of peeking into transport layer. Unless and until you're working in a bridge mode or what is known as a transparent mode where you get into data link layer, well, this is where all your LAN and WAN technology comes into picture. In data link layer, everything is checked in hexadecimal format, so you have different ether type, frame type, different LAN WAN encapsulations. So that's your link layer. Okay, the address used over here are MAC address in terms of Ethernet. You want to get into frame relay, DLC, ATM, VPI, VCI, so on and so forth. So these are the three layers at which we have a terminology of packet used, and well, packet was created to ensure that the delivery devices do not have to deal with the content. They will have information in the header good enough to make them deliver the courier. Now this term packet means we have a header, and then we have contents data, and finally followed by a trailer. So what I want to get in the header, well, everything which I mentioned over here, all your protocols at any of these layers, addresses, port numbers. If you're using, let's say, TCP, then your TCP three-way handshake information, all TCP flags, sync acknowledgement, reset, fin bit, whatever, it's all coming at header. And when you say packet filter or even packet forwarding for that matter, you actually don't look at the entire packet, because the packet consists of these three parts. So it is header, it is data, it is trailer. Well, you don't worry about any of that. You only check the header. I should call it header forwarding or a header filter, isn't it? You're not checking the data and you're not bothered about it. If I'm a router, I'm a switch, I'm not really concerned what are the contents. Is it an HTTP? Is it a SAP? Is it an Oracle? What sort of application it is? Is it the voice traffic, video traffic? I'm just looking at the header, and I have to move this information to the destination. So before packet filtering came into existence, very important. So before packet filtering came into existence, 1990, we had packet forwarding technologies. Now, packet forwarding technologies is there since the birth of internet. We're talking about 1971, 72, routers and switches. So a router is supposed to forward, and forward on the basis of what? Layer 3 information, destination address, right? So the term packet is there much more before the terminology of firewall or definition of firewall was introduced. Now this is something very interesting. You are introducing firewall on a router. A router is supposed to provide packet forwarding. Okay, and what are you saying? Okay, hello, please do packet filtering for me as well. Can you do that? So you're putting an additional burden on the router. You're telling the router, boss, what you're doing is packet forwarding, right? Now can you do me a favor? Can you just do an extra process and filter the packet, and we can have a bit of a firewall, you can apply a policy and so forth, right? So that's what we are looking at. Now my question is, well, is this what you really want? Are we going to have any trouble with this? It's like a device which was created, which was developed and oriented toward packet forwarding. And for packet forwarding, you are in a rush. You're not mad rush actually. You just want to look at the header and just forward. So you want to forward like crazy. That's what a router is supposed to do, or a switch is supposed to do. Then you say, hold on. It's like you get into a security check on an airport. So you are in a rush to get your plane, but then security check will say, oh, okay, sir, please wait. Yeah, let me see your ID. Let's scan your luggage inside out, basically. So yes, you need to halt. This process requires time. Okay, it's a time-consuming process. Many of you think, okay, this is an unnecessary process, a wastage of it. But then, well, security, is important, and we learn it hard way, right? So yeah, you are introducing another process, okay, on a router. Okay, but then we are continuing with the same format. We are telling router, sir, please check the header. So the packet filter, I'm not going to check the contents, and the contents are what? The actual application. So in the header, if you write down port number 80, so I'm going to assume the data is HTTP. The data might very well be an RDP tunnel over HTTP. You never know. You're not checking the contents. Now, is that good? Do we require the same logic for packet forwarding, which is used on a router, and this logic is good enough for security? Is security and routing similar, or are they different, right? So these are the things. And keep in mind, those who want to learn ACL, this is not the video, okay? I would be talking about ACLs, etc. But this video is not about access controllers. This video is about what is packet filter firewall technology, and then what are the chinks in the armor, what are the disadvantages, what are the issues which we have, and why in 1994 a Checkpoint, a Israel-based company, shifted to US and came with a patent of stateful packet inspection. The world took notice of it. So we are talking about the issues and the shortcomings of this technology, how effective it is and how ineffective it is, and then we have to move on to the next technology. Okay, so this is the reason why I require a stateful packet inspection. Okay, so my aim is to point out the issues, not just to talk about ACL. Okay, so I can say that when you introduce access control list on a router, you started with a compromise, and this compromise was supposed to have an impact in terms of security. The other way around was to introduce or rewrite your internet operating system, maybe redesign your hardware stuff. That requires a lot of time, investment, energy, etc., and motivation. Why should I do that? So Cisco didn't see any merit in doing that. We were in earlier stages of security of firewall technologies, and well, access controllers was considered good enough, at least from the basic point of view. So packet filter. Okay, we are just going to keep in mind one very important thing. When you say a packet, it is in terms of packet filtering technology or even forwarding. Well, actually it's not a packet, it's just header. You simply do not worry about this. Okay, coming back to the slide. So first firewall model introduced in 1990 checks only content in the header, and it does not check the content. Obviously it's going to create a huge problem. Stateless firewall, a return traffic issue. Now, as I told you that we are going to check access control list for these shortages, these disadvantages. Okay, now one of the prominent and most crucial issue with access control list is what? It is stateless. What is stateless? What do you mean by that? Stateless basically means that you do not maintain connection status. So when the traffic goes across the firewall does not maintain a connection. I'll come to that later. Now what I'm going to do is I'm going to click to the next slide and let's talk about ACL configuration parameter. So let's get used to a little bit about ACL, and then we'll get into the disadvantage of it. So what are the protocols which an access control list is going to check? So as I told you, at transport layer, at network layer, and if you wish at data link layer, all the protocols, TCP, UDP at transport, and rest of them are in network layer. So header is going to check the protocol. It's also going to check the source and destination addresses. Okay, you have combinations for source and destinations, like you can mention any, you can mention a subnet by using wildcard mask. You can play around with the network subnet part. You can be specific for host, or you can use any. So that is part and parcel of ACL configuration. Okay, how do you define a network, source or destination? Port numbers, TCP UDP port numbers to identify applications. So any application is identified by using a port number. So actually we do not identify application by checking the actual content. Okay, the only way to identify application at this layer, okay, and this particular device is to check the port numbers. Matter of fact, you're going to blindly assume if there is a port number 80, it is actually a web server. You have to assume, you are not checking. That's the risk. If you're using TCP, you can say as far as your configuration of ACL is concerned, so you can check all the TCP related flags, sync acknowledgement, establish, reset bit, and all the options can be checked. For further security, we have IP option fields. Now IP option fields are CPU bound, so they have to be processed by the CPU. They can create a bit sort of a DOS attack, or you're putting additional burden on the CPU. So IP option field, we're talking about IPv4. v6 does not have an option field, but IP option field, IP precedence, DHCP, all these parameters can be configured on the ACL. Now, before I move further, what I'll do is I'll try to explore a little bit about ACL, and this is a setup which I'm using right now. Okay, so this would be the setup we will be using for testing out our practicals. Okay, and all the concepts of packet filter as well as other technologies. Now in my topology, I have two segments for the private VLAN 5 and VLAN 6. These are my private segment connected to a multi-layer switch. The multi-layer switch is providing inter-VLAN routing as well as connecting with the internet edge router. Now internet edge router basically means this is a router which connects me and my private network to internet. Obviously if you are going to travel to internet, you are going to come to this router, and then this router will have option and opportunity to apply NAT, access controllers, etc. So my ISP link is using a public IP, and the private network we are using private IPs. On ISP we have a server which is having FTP web services running, and the IP address is 4.4.4. Now a lot of this stuff is already ready. I'm not getting into the basic configuration of IP address, VLAN, etc. So I do have basic configuration over here, and let me quickly take you through that. What do I have? So just we want to keep the topology in the mind. So this is the topology. Okay, router is acting as a test PC. I do have a device connected using VMware over here, so I can use web browser, etc. There is a multi-layer switch. Multi-layer switch is running EIGRP with 1. So let's go to the multi-layer switch. If you see the VLANs which we have currently, I'm using GNS. So I have 3 VLANs, okay, 5 and 6 for customers. So this is my private network, and 7 I'm connecting with this with the router 1. It's a multi-layer switch, so I have SVI interfaces. 80 and 90 is again for the private PC, and 100 is going to the router 1. So if you look at the diagram, 80 and 90 for my private segments. So I have 2 private segments I would be using for sending traffic, and 7 is for connecting router 1. Okay, so this is VLAN 7, and the IP address is 11600. Between switch and R1 I do have EIGRP. So I'm running EIGRP, and all these subnets are authorized. All my private subnets are authorized to R1. So R1 is my edge router, and I'm getting all my private routes over here. Okay. So there are 2 interfaces. This is the private interface facing the private network, and this is my serial interface which is connecting me to internet. Now obviously if you wish to send traffic from private to public, you've got to have NAT configuration. So I do have NAT configuration. My NAT pool is basically a public IP of 20.1.1 to 10. Okay, the NAT is already configured. Again, you need to know a little bit about these technologies to understand this video. So I'm doing translation by using a public pool of 20.1.1.1. My private interface obviously will be FS0x0, which is my private interface. And this is my inside interface. Serial port is going to be the outside interface. So route is there. How do I connect with ISP? Well, we always go for a static default route pointing towards service provider. So you wish to go to internet, well, there are multiple millions of routes. So the way you access internet is either you go for BGP, or well, 97% of the people configure a static default route pointing toward router 2. So R1, my ISP edge router, is having a static default route pointing toward my service provider, and then I am redistributing this into EIGRP. Okay. So once I do the redistribution, my switch also get a default route. So if you wish to move to internet, well, you would be using the default route. So if switch receives any traffic for which does not have a route, it is going to go to R1. R1 does not have a route, it is going to go to ISP. Both these PCs, test PCs, are having a default route pointing toward the multi-layer switch. So you go to multi-layer switch, goes to 1 and goes to 2. The ISP router obviously will not have any of the private routes. Oops, router 2 is my ISP router, and it does not have any other private route. Okay, so the traffic has to come to router 2, it has to be translated. Okay, so let me just show this to you. I go to test PC. Test PC is right over here in VLAN 5. Okay, this is nothing but a router. So I have disabled routing and configured default gateway. So you are sending your traffic to multi-layer switch 170.16.90.10. Now the destination is 4.4.4, which is my private server over here. So you're going to multi-layer switch, then you're going to the edge router, you're going to the service provider, and then finally reaching the destination. So now if I check the destination, the server is responding to 20.1.1.2. Okay, and the reason is that on the edge router, on the internet edge router, we are performing translation. Without translation, you cannot access internet. So when I receive traffic from 90.1, okay, we are translating the source address into the 20.1.1, which is the public address, and then sending out to the destination. So we do have a basic reachability just to explore the topology to you. So this is my topology. Now, as I told you that I would not be focusing on access controllers, what is standard, what is extended. However, just for the sake of it, just for the sake of understanding, let's just go a little bit into the standard and extended. Now, first of all, you would not be using standard ACL for security. Standard ACL can be used. Okay, only for management ACL. So if you want to use standard ACL, well, the only reason why or only way you're going to use standard ACL is for management ACL. We know that standard ACL we cannot manage, we cannot mention destination, we cannot mention destination port, TCP, UDP, nothing can be mentioned. Only source address is mentioned. What do you mean by management ACL? Okay, so let's say you are on router 3. Okay, and do we have telnet access on this? So let's configure telnet access on this. Now I can access router 3 using telnet. Okay, so let's try this out. Right, that's working. Now when I say management ACL, what I can do is I would like to control who can access telnet on this device. So I say access list 1, which is a standard ACL, and I say permit. Let's permit 170.16.90 using a wildcard over here. So I would like to allow, sorry, we are doing translation. Okay. So I need to mention the translated address, which will be in the pool of 20.1.1 0. Right. The original address of 170.16 will get translated to 20. Right. So I'm going to allow this. Right. Now you will ask, okay, so how can I use it for security? I mean, 20 can access what? Well, 20 can access anything going by the access control list. In standard access control list, we cannot mention destinations, protocols, nothing, right? But then when you're using it for management ACL, you don't require it. How? So I go to line VTY 0 space 4 and I say access class 1 in. I see. I don't have to worry about service because I am putting it into VTY, right? So it is getting effectively I'm using it for telnet. Destination is telnet, right? That goes with the configuration. Destination, well, I myself is destination, right? So you don't have to configure the protocols, destination, nothing as far as management ACL is concerned, right? So this is going to work fine over here. Okay, it is going to filter telnet traffic coming from any port. Okay, as long as the source IP is this. If source IP is anything else, let me put a lock over here to test it. Okay, so as long as the source IP is 20 dot blah blah blah, it's going to be allowed. Nothing else is going to be allowed. You see, I am using standard ACL, but the effective part is that I am controlling access to telnet, which is an application, and the destination is myself. That's the only way your management ACL, can be used, or management ACL can be configured using standard ACL. or you can say standard ACL can be useful for security. Otherwise, we are not going to use standard ACL for security purpose at all. So let me try. I'm still able to access telnet because my traffic will match the access list. Okay, what did I do? Okay, let me add one more statement, deny any log as well. Now, if I try to access from R1, R1 is 115, so we will not be able to access, okay, because R1 will be using a source address of 115. So let me try that out. R1 is my ISP edge router. I'll try to access 4.4.4. Okay, the connection is refused. If I go to 3, the access log is saying, well, you are not allowed to access. So the only way your standard ACL is used or can be used is in the management format. You can do it for HTTP access. For we're using it for telnet SSH should automatically works out. You can use it for HTTP, HTTPS as well. But then that is the limit of it. We are not going to use standard ACL for all practical purpose for security. It is going to be an extended ACL, that's for sure. Okay, so that's about your standard ACL. Now let's try to see. Let's just focus on the configuration of extended ACL. What are the parameters we have? Okay, now let's go back to the slide again. What I was saying. So in extended ACL, we can have protocols. Protocols could be any of this, source and destination, any of the combination. You can have any, you can have host, you can have network or subnets using wildcards. If you're using TCP UDP, you can mention port numbers. If you're using TCP, you can also mention flags. Multiple TCP flags can be mentioned. And you have also IP options, IP precedence, DHCP, QoS parameters which can be mentioned. So let's just have a look at the CLI of access list. Now we can use named ACL or we can use the numbered ACL. Always advisable to go for named ACL. Allows you editing, moving lines, etc. So I'm just going to give it a name test, and we would just like to get ourselves familiarized with the options which we have. So permit what? So first thing which you mention is protocol. Okay, the protocols are having number from 0 to 255. Actually start from 1. Let's say you mention 89, so we're talking about OSPF. Okay, you mentioned 47, so you're talking about GRA. You mention the protocol or you mention the number. If let's say you would just like to discover what is the meaning of 47, so type 47 and check your access list by giving show command, and it will show you that 47 is GRA. So if you're wondering between 1 to 255, what protocol stand for what, you can just try out the number. But this is my protocol. Okay, let's say my protocol is TCP. Okay, and that means now all TCP related parameters are going to work. Okay, then in TCP, what is a source? So these are the options which I have at source. Okay, I can mention source as a particular IP address. Okay, a 32-bit match. I can use wildcard mask for defining subnet and networks. Okay, we also have an option of object group with the latest operating system. So let's say I take it any. Okay, then the destination, same option. So this is source and destination in terms of networks. Okay, let's say my destination is blah blah blah. Okay, so what I've done so far, TCP uses a protocol, and since I'm using TCP, I get all the options which goes along with TCP. Then source and destination. Okay, this is 3 into 3 combination. What are the 3 combinations? Any, host, network or subnet. Okay, why 3 into 3? That means in source or in destination, 3 into 3. Okay, so what next? What else we can configure? Now you look at established. I will be talking about this, how we use established to match written traffic or acknowledgement or reset bit in the TCP flag, but you say fin bit. So these are TCP flags. Okay, you have option of reset, sync, etc. You have fragments options. So if TCP fragments are supposed to be allowed, option not equal to. Okay, you see multiple options are available over here, including TTR parameters, right? TOS, which is basically going to define your quality of service parameter. Urgent again is a TCP flag, right? Multiple options are available. Now I can say equal to which port, so you can mention the port number over here. Okay, port number 21, right? or any port number. So we are defining the service or application. We can use range, and a range of ports can be mentioned over here. I would like to match everything between 1 to 1023, right? I can mention not equal to, okay? So we are negating the option, right? But source, destination, and the port number. Let's say I give 23, then I'm looking at telnet. So this is TCP. Now you can come back, you can say IP, so now I'm looking at layer 3. Okay, say any, and now what are the options? Option change. So if your protocol is IP, okay, then you're looking at layer 3. Alright, TCP, UDP doesn't matter now. So if I say IP any, that means whatever is there in TCP and UDP, everything is allowed. Okay, I'm no longer looking at TCP and UDP. Okay, so if I mention TCP, so I'm looking at a transport layer stack, I'm looking at network layer stack. Okay, so we are bothered about whether the protocol is TCP or UDP. Okay, then we have to look at the IP addresses, source and destination. Okay, so both the things are matched. Now if I just say IP, okay, and I say any host 4.4.4.4, I don't have option of mentioning the ports. That means anybody can access any application, whether TCP or UDP, as far as the destination is 4.4.4. So the only thing I'm trying to match over here is destination 4.4.4. Nothing else is matched. Everything else is allowed. We can also see if you're using IP option, you have these fragments, right? So you're looking at fragmented packets, okay? IP option fields if you want to match, okay? And then you also have DHCP parameters, IP precedence parameters, right? And this can differ. I mean, this can just increase a little bit based on the latest operating system. You know? So one critical factor over here, when you say IP, so you ignore the transport layer, okay? So whether packet is TCP, UDP, what is the port number, everything is inclusive. If you wish to be specific about application, then you have to start with TCP or UDP, okay, if you want to filter based on applications. All right, so just a basic configuration idea about access control list. As I told you that this particular tutorial or this particular video is not about how to configure standard or extended, okay, I'm just helping you out with a little bit understanding of standard and extended ACL. Okay, so I would be wrapping up this video now, and in the next video we will be looking into the issues which we face with access control list, what are the shortcomings, and we'll practically then testing it out. Thank you very much.